Hey, everybody, and welcome to this week's episode of Packet Protector, the podcast at the intersection of networking and security. As always, I'm Jennifer J.J. Manella here with Drew Conry Murray, and today we're taking a little bit of a technical deep dive into microsegmentation.
Where did that pronunciation come from?
I don't know. It's French. Doesn't everything sound better in French?
I'm not sure about that one. Baguette, yes. Microsegmentation, I don't know.
If I tried to say it in German, it would probably be like 8 words strung together, like
Yes.
the thing that makes the dividing up of the other stuff into very small pieces technology that we use.
Yes. No, we're not going to go German for this one either. JJ is actually going to be our expert guest today because this is an area that she focuses on in her consulting and has presented about it. So we're going to talk about sort of what microsegmentation is, how it relates to the concept of zero trust and the product category of zero trust network access, things to think about if you are going to try to integrate microsegmentation in your own network. And we'll also maybe talk about some products that you can think about if you're looking to do microsegmentation in a variety of different categories. So stay tuned. We're going to dive in, maybe have a notebook. A lot of notes you're going to want to take. We'll get started. Okay, so JJ, let's get into it and start with the basic question. What is microsegmentation? What do we mean by that?
Okay, so I thought it would be fun to see what ChatGPT says about it because I have my definition, but it actually aligns pretty well. I find myself correcting ChatGPT a lot when it comes to networking and security concepts. But here's what it says. It says microsegmentation is the practice of dividing a network into small, isolated segments down to the workload or application level and applying granular security controls between them, blah, blah, blah. And then instead of relying on traditional perimeter firewall, microsegmentation enforces least privileged access between systems, even inside the same network zone. Now, it's talking about it more in the context of firewalls and application and workloads, but I think the even inside the same network zone is where we start to really draw the line between what is, traditional network segmentation that we have at layer 2 and layer 3 versus microsegmentation.
Okay, so that's why here in our show notes, Doc, you've bolded the phrase even inside the same network zone, meaning we're not just talking about like a VLAN or some other typical network segment. We're talking about something more defined.
Yes, in my definition. Now, here's the thing. There's not like a Bible of security terms for LAN and for, workload. But here's the thing that we'll talk about here in a second, which is that the microsegmentation phrasing, like that term, actually was born out of, data center technologies for, as ChatGPT references, workload and applications. So you're talking about microsegmenting servers, services, microservices, applications, which is fundamentally different than, I'm air quoting, microsegmenting something on a LAN. Wi-Fi LAN, wired LAN, whatever it is. But, organizations, vendors started using microsegmentation because they were actually doing this with applications and workload. But all of us on the networking side went, well, microsegmentation sounds cool. We do that too. And therefore, every networking vendor, every NAC vendor, every vendor out there just started slapping microsegmentation on every product.
That's, I think, one of the reasons we want to talk about it is to get more of a working definition so that when we say microsegmentation, we're kind of talking about the same thing. So how would you compare microsegmentation to something like just a VLAN, a traditional VLAN?
Well, I think that even inside the same network zone is where we can kind of start to work with that and tease that out. So if we consider, an IP subnet or a VLAN, a network zone or set of resources, segmenting within that, I think is where we're aiming when we talk about microsegmentation.
Okay, that's the micro part.
Yeah, I think so. And this is kind of where I draw the distinction, having done network access control technologies for, over 15 years, I'm not knocking using traditional layer 2, layer 3 constructs where we have a VLAN, an IP space that we're working with for segmentation. But the problem is that it doesn't scale well. So if you start thinking about VLANs across an organization, you have to get the VLAN all the way down to wherever that edge port, whether it's a wired or wireless port, all the way back. So even with the manufacturers that have the automagical, VPN distribution, it does not scale well to start to add VLANs for every little use case, or every little mini network that you might need. And of course, we have limitations of VLANs. 4096 is typically, most infrastructure.
Yep.
So yeah, if you want to talk about microsegmentation, we want to get more granular than a VLAN.
Okay. And we're also talking about another important part of this is workloads, applications, and even users in some cases with microsegmentation, yes?
Yeah. So I take, zero trust and microsegmentation, and I kind of put them into 3 use cases, 3 big buckets. So the first bucket, with the easy bucket being that workload and server or service segmentation. So that data center microsegmentation.
Give an example of that.
Yeah. So if you had sets of servers or services, so this is, especially pertinent up in the cloud, whether you're in a cloud or between clouds, and, this application needs access to this set or service of a database, but it doesn't need access to the whole enclave where that other resource is living. It only needs access to that one little sliver of something. You can get down to the microservice level and you can put policies that says, this application has access to this, you could say server or database or these ports, but it can get down into services and microservices. That's that data center and workload segmentation.
Okay, so more fine-grained, I need this application to be able to talk to this database, but only this database, not every conceivable database that I might have in a larger network segment.
Right.
Okay, so that's one. What's the next?
Then we've got what I think is the next easiest one, which is a user accessing something. So this is where there's a human, usually a traditional full operating system. We have a way to input and interact with that device. And therefore, we typically have a way to put some type of a software agent on it, or it's got an interactive browser on it. And so then that user using a device is accessing a resource. And that's that second use case. So this is where I'm sure we'll talk about ZTNA coming up, but the Zscalers, the Netscopes, the Catos of the world that are doing that type of micro-segmentation of controlling, think of it like a VPN replacement. Because when we do VPNs, despite what everybody thinks we do, typically, we drop a user into a relatively large set of resources. Very often we're dropping them in as just they're sitting in their office and they have access to everything on that air quote production network. Some organizations do a little bit better job carving things up. But typically, once you drop into a VPN, unless you have done a lot of extra work for groups and stuff, that user has access to a large set of resources based on the network they dropped into. So if we get into micro-segmenting that with that user to resource, now whether the resource is on-prem or on the cloud, we can get really specific about when, where, and how that user can access that thing. And the whole principle of, the overarching zero trust architecture is you're not given access based on where you are connecting from. Because you're on this network. So if I'm sitting in my office, a lot of the way we've been working for decades is, well, if I'm sitting in my office, I'm in the building on campus, I'm dropped onto whatever production VLAN that is, 12, and I have access to whatever is on VLAN 12 and then probably some subset of other resources depending on permissions.
Yep.
We're doing away with that and we're saying you have to have explicit, because zero trust doesn't mean no trust. It really just means explicit trust instead of implicit trust.
Right. So the old traditional IPsec VPN, I'm a node on a network. I've got an implicit trust to whatever else is in that VLAN or other potentially associated VLANs. Zero trust network access is more, as you said, explicit permissions.
Yeah. So again, you can get down to, specific server or application or service somewhere.
But we're also not just relying on network level controls like a VLAN to do that segmentation. You can bring in an agent, and that agent can inform your access based on things like where you're coming in from, the state of the device you're coming in on, that kind of thing.
Yeah. So what happens further up, the OSI stack, if you will. So we're talking about in the vendor neutral industry terminology of zero trust. A lot of it follows the language we use with the trusted computing group, trusted network connect models. So you'll see a lot of similarities between what we were doing with network access control and zero trust, even though there's a lot of differences. And so we talk about a policy enforcement point. What thing is actually controlling? If I set a policy and say you are or are not allowed to get to something, what is enforcing that? And so with this idea that we've got a user accessing something where we have some type of software, it could be an agent that sits on the device the user's on. It could be an agent on the resource that they're accessing, combinations of those things. It could be agentless. So if I'm using a device and I'm accessing a web-based application, there are agentless options that use reverse proxy. There's other kind of virtual firewall things we can do, but it's all software at that point, which is why we can do super granular stuff with it.
Okay, so there's more software. And before we get to the third version of microsegmentation, is microsegmentation a subset of zero trust network access? Are they different things? How would you kind of Venn diagram them? Microsegmentation and zero trust.
Okay, I think there's three terms. You just mentioned three different terms that have three different meanings. So let me kind of break that down. I'm glad you asked it because this is the first conversation I have with most clients and organizations I work with. So zero trust by itself, we talk about zero trust strategies, zero trust architectures, which is a concept. Just like we used to say layered defense or defense in depth, right? It's an approach. Yeah.
It's an idea, yeah.
ZTNA.
Zero trust network access.
is zero trust network access, which is actually, much to my dismay, a class of products designed to address the second use case that I mentioned of a user accessing some resources, applications that might be on-prem or in the cloud somewhere. And depending on the product, like they do it different ways. And we're starting to see the lines blur between ZTNA, VPN overlays, a little bit of like SD and SD-WAN, SASE and SSE. But the lines are kind of blurry. I do have a Venn diagram showing a little bit of that. But, you know, at the end of the day, zero trust is a strategy. ZTNA is specifically a subset of products for a user accessing a resource somewhere.
Okay.
And you can think of it like a VPN replacement.
And then where does microsegmentation fit into this?
Okay. And then I would say microsegmentation is a means to achieve certain zero trust principles. So in zero trust, there's lots of definitions depending on, you know, whose paper you're looking at and whose Kool-Aid you're drinking.
Right. Which vendor presentation you're watching.
Yeah, but you know, some of what we talk about in zero trust, and one of the common misconceptions that I hear from individual contributors, usually not executives and leadership within technology and security, but typically, you know, the engineers, because we're just glassy-eyed with all the products shoving, you know, air quoting zero trust products down our throat, and it's the same thing we were buying 12 months ago. It kind of makes us feel like, well, this really isn't something new. It's something we were already doing with a new name, or something we were already supposed to be doing with a new name that we just haven't done yet. But principles of zero trust, you know, there's stuff like in the federal guidance, it'll say things like, you know, traffic should be encrypted and inspected. We enforce strong authentication. We're using multi-factor where that's appropriate. And I think that's all kind of in the bucket of the stuff we've been doing. But what we're shifting to is talking about access that's dynamic, and not just dynamic like on demand, but has dynamic inputs that I'll talk about in a second. That it is just in time, that we're following least privilege. So again, instead of dropping somebody into a whole, you know, network, subnet, VLAN, and letting them have at whatever's in there, we're being really prescriptive about you have access to this server, service, or application. When we get into privileged access, we talk about access that might be brokered. So I'm not given the keys to the kingdom. I'm given privilege to go request access into something that is in brokered for me. So if my credentials get stolen, nobody can just log into that thing as me. When we talk about cloud connected resources, we also talk about like dark cloud principles, which not all vendors do this, but some of them do. When we get into like that ZTNA architecture, which is that service or application that's floating on the internet, is, I hate to use the word obscured, but it's not visible publicly. And there's different mechanisms. You know, the Cloud Security Alliance has an SDP protocol. There's port knocking. There's all types of ways that vendors do this. But the idea is that if you just start scanning, like let's say I know, you know, Drew, you've got servers set up at your house or your business. If I start looking at your public DNS entries, if I start scanning your public IP addresses, I, through dark cloud principles, wouldn't be able to even see that you have services and ports open. So that's kind of new. But I think the biggest change that impacts us in traditional networking, in zero trust, we talk about security posture through trust inference. And what that means is we're getting telemetry from other stuff. Sometimes the stuff is external. It's like, you know, were the credentials actively leaked on the dark web? Does the device I'm on and using have some CVE tied to it that's exploitable? Does the asset that I'm accessing up in the cloud or on-prem have a CVE that hasn't been patched? Or it could be something more internal and dynamic with inspection with the endpoint, the user account, et cetera. But the challenge I think we have on the traditional networking side is our vendors like to do their own thing. And so getting these trust inferences, what that really means is a more open ecosystem. It means connecting with APIs into different products and getting information back into our system, or trusting information back in from somebody else's system. And I think with those other use cases, when we talk about user access, ZTNA, workload segmentations, there's more standardized and open connectivity for a lot of that. And on the LAN side, we just don't have that.
Okay. So to bring it back to microsegmentation more specifically, when folks are talking about microsegmentation, does that generally imply a particular part of the network like the data center or remote access?
Yeah, I think, well, we're getting to the point where we can start to do microsegmentation on the LAN. But most of the products that have been out there for years are addressing those other two use cases. It's a new area really in the LAN space.
Okay, the traditional campus network.
Yeah. So back to your question of like microsegmentation and how that fits into zero trust. So out of those principles, microsegmentation helps us do that least privilege and least access model because we're not letting a device or a user access resources on a whole subnet or VLAN.
So typically then, what are the methods I'm using to implement a microsegmentation strategy? Is it just like on switches, on routers, on firewalls, or can I employ other tools?
Yeah, it depends on the use case. So the first two we can do with software. I'm using software loosely. Software could mean an agent, it could be that agentless model I was describing. But when we get into IoT devices, OT devices, headless devices,
Right, no agent available.
yeah, or, and I think this is a commonly missed use case, a traditional operating system, but you don't own it or you don't manage it for some reason. And I see this a lot in everything from utilities to manufacturing, OT environments, healthcare, right? You have this thing, maybe it's running Windows, but the partner or vendor that you're working with actually manages that thing and you can't put your stuff on it.
Okay, you're not talking about a contractor coming on site. You're talking about like, I don't know, an MRI machine that has an operating system underneath
Exactly.
and you can't touch it because it's managed by a third party.
Yep.
Okay.
Yeah.
Okay, so this is a case where I can't use an agent on that device, so I am forced to do other things. What else would I do?
Yeah. So then you get into with that third use case. Now, if we can't do magical software granular stuff, now we have to turn and look back into the traditional network infrastructure and say, back to that policy enforcement point, right? If we can't use software, because the software can do stuff, it can manipulate DNS, it can do host firewall things, it can change the local routing table. Like it can just do whatever it needs to on an endpoint to manipulate its behavior and segment it, quarantine it, whatever.
Yeah.
If we can't do that, what we have to do is our enforcement point is the network. So now we're back to, I hate to say it's a downgrade, but it is more challenging because it's more manual. So, we might have, I'm going to make up a term here, a zero trust enabled firewall or a zero trust enabled switch. And what we're hoping with that is that we get to a point where, so, traditional networking constructs, right? We have VLANs, which is layer 2. We have access control list, which is working, of course, at layer 3 typically. Yes, there are access control lists for layer 2 as well. But, typically we're working with layer 3 there. And those could be static or dynamic. The truth is a lot of NAC products can do dynamic access control lists. That does not scale very well. I've seen that. And I'm not picking on any one vendor across all of them. That has just never worked well. We can do things like software-defined networking. We can do other virtualized constructs like VXLAN. And I'm kind of using these as going from like coarse segmentation, very rough segmentation with the VLAN, to now something that's a little more mature and a little more granular when we get into like VXLANs.
Right, because for one, that gives us many more virtual networks to work with.
Right, yeah.
And if you're looking at something like an NSX, formerly Nicira, that gives you even more granularity and more options for enforcement by doing things like supporting virtual firewalls and so on throughout this fabric you're creating.
Yeah. And those are typically, more on the data center side, but same concept applies there because in a lot of our traditional, data center applications, they're not all modern enough for us to embed that enforcement point in it. And so what we have to do is put something right in front of it. So same idea here.
Okay. What about something like DHCP? Can I incorporate that into a microsegmentation effort to give me some sense of maybe what at least type of device this is?
You mean for like profiling?
Yeah, for fingerprinting. Yeah, or profiling, yep.
Yeah, that gets a little quirky. So we've done DHCP fingerprinting for a long time with NAC. And we tend to kind of layer that with other stuff because sometimes we can't tell a lot from the DHCP fingerprinting. Sometimes things have statically assigned addresses. Typically the more important something is or the less visible it is to us because somebody else is managing it, those are typically the things that are statically configured for one reason or another. And I know it sucks. So like for a lot of organizations, I was talking to a utilities client a few weeks ago and, they spent, so let me just preface my next comment with it's a very large organization, but they spent well over $1 million just doing a kind of an OT segmentation exercise and further pulling out their OT environment, operational technology from the IT environment because every asset that they had on the OT side that they needed to change the IP addressing for or change anything, right? Use DHCP, don't use DHCP. They have to put a ticket in with that provider and there's a charge associated with each of those service requests. So I do understand, like, a lot of the guidance that we get out there is challenging, or it has like this domino of just crap behind it. Like you think, oh, this is no problem. You see these no-brainer re-IP, just, point to their DHCP server or scope and do this other thing. It's not always that easy.
Okay.
But for fingerprinting, I mean, that is one way to fingerprint. I would say that we don't get the best information from that because, again, it may not even be happening.
I was just thinking of that sort of, a hospital device with an OS that I can't touch. Maybe the best I can do is infer some kind of information about it based on things like DHCP.
Yeah. And for something like that, you'd probably get some pretty good information. Yeah.
Okay.
But then the question is, once you know what it is, how do you control what it has access to?
And that's where we get back to the network has to become sort of that policy enforcement point.
Yeah. Because a lot of organizations, especially with like IoT or healthcare devices, like all of that stuff.
The technical term.
Yeah. The technical term for all of the IoT crap you deal with. Most of them, frankly, unless they have a purpose-built solution in place, whether it's wired or wireless, and of course, a lot of these things are wirelessly connected, they throw up an SSID or create a VLAN, let's say it's VLAN 86. And that whole population goes on that VLAN. And that's one of the challenges we're trying to deal with now, because in addition to, we talk about why are we doing microsegmentation? There's a lateral movement component for malware and ransomware, because, when one device becomes infected, the first thing it does is it starts to crawl out and see what else it can get to. So if we can stop that from happening at that level, right, at that part of the kill chain, I guess, then it doesn't matter how it stops, whether it happens in software or happens from the network. But if we can stop device A from contacting devices B, C, D, and keep going, that malware cannot spread.
Okay, so the idea is instead of just putting all of these one class of wireless IoT devices into VLAN 86, okay, I've segmented it from the broader network, but I've also essentially just created a pool where if malware gets onto one device, it can easily go and compromise all the other devices within that VLAN, and I've still got a problem.
Yeah. And I think there's different ways I'm using malware as a big bucket. So we can talk about it like ransomware that might spread on a computer, between Windows devices, or if we get into the IoT space, we have, Drew, we cover all of these like IoT vulnerabilities, right? The CVEs and the KEVs daily. I saw one, from one of the camera vendors again today that came out with a remote code execution. So there's a few different risks. Like if you were to threat model this and we say, what is really the risk associated? Well, the first thing is all of those IoT things in any organization, there's different classes from a risk perspective. And what I mean by that is there's going to be some things that's like, the sales team has their Sonos speakers so that they have their walk-on music during QBR. That's Drew's laughing. He's doing the quiet Muppet laugh. You're laughing, but it's true.
Yeah. The thing is, I can picture it. That's the problem. I can picture it.
The number of CISOs that ask me about Sonos speakers, it's an unsettling amount of concern around these. Anyway, but you have that, right? Who's going to get hurt if something happens there?
Sure.
But then you might have, as we go through life, we have like building and facilities management. So if suddenly all of the doors are locked or unlocked, or the lights go out in a building, depending on what that building is doing and who's in it, that could be a huge problem.
Yeah.
If the HVAC system goes screwy, all of that.
Yep.
In hospitals, we have, temperature sensors that are connected to very expensive cancer treatment cooling systems, right? The refrigerators. So there's a much higher risk with some of these devices than others. And there are also varying degrees of vulnerabilities. And so it becomes really challenging to track, because if you made a grid, you start going, let's say, risk on one axis and then how vulnerable is that device on the other, because some devices are going to be patched and serviced more regularly than some of the other devices. Maybe there's smart plugs, maybe there's smart lighting, maybe who knows.
Right.
So, and then of course in healthcare, you're talking about all of the machines that are servicing humans.
Right.
Infusion pumps, et cetera. So by lumping all of these things into, one or two networks, when really each of those things probably only needs access to, in normal IoT stuff in an office, maybe it just needs access to the internet. But in other cases, maybe it needs access to, one or two servers inside of the organization. You can't VLAN your way out of that.
Okay. So that's what I'm going to need to get into microsegmentation.
Yeah.
But again, if I can't get software onto the endpoint devices, I might still be forced to go with a network-based approach.
Exactly. Yeah, I think I said there haven't been many players in the space. And I think one of the reasons we wanted to have this conversation now for the listeners is because I would really like to start to bring some of those people on whether it be a thought leadership conversation about where the industry's going, or even just, a sponsored episode where they come talk about the solution, because this is where security and networking has a huge opportunity to combine forces, and the networking team and architects, if they have the right information, can make absolutely fantastic decisions for the enterprise. But you have to know that these things exist and which things are, if everybody's labeling everything as zero trust and microsegmentation, how do you know which thing is the right for your use case? And it's overwhelming. You can't tell from their websites what they do.
No.
I know what they do, and I can't tell from the websites what they do.
I agree with you 100%. Yes. Yeah. We need more clarity on the vendor side. I think we sort of started talking about this in terms of understanding, risks and the types of devices we're talking about. But what are some things I should be thinking about things like user and application traffic before I should start considering my microsegmentation policies and how I'm going to approach it?
When we talk about building a zero trust architecture, I subscribe to the 5 steps. We use this in the Cloud Security Alliance. So, some of the volunteer work I do is with the Cloud Security Alliance and their zero trust working group. We did just put out, a fantastic white paper around zero trust in OT and ICS environments.
Mm-hmm.
So that's freely available on the internet. If you look for, CSA, zero trust for critical infrastructure, it'll pop up. We'll put a link in the show notes, and all that's free. But there's a 5-step process, a roadmap, step 1, step 2, step 3, step 4, step 5, that's very different than the 5 pillars we see in a lot of the documents. So the 5 steps are: define the protect surface, which has to do with just asset inventory and understanding what you have. The second step, which I think answers your question exactly, it's defined as map the transaction flows. And that just means you need to understand which things and people need access to which resources.
Yep. Mm-hmm.
So understanding the transaction flows. Now, this 5-step we reference it in that OT document, but this is the same 5-step model we use for everything. Great. Cloud microsegmentation, user to resource segmentation, land-based network microsegmentation. It's the same process. It's the same 5 steps. So know what you have, figure out what needs to access what. Then you get into architecting, so designing the zero trust architecture, which is planning and documentation. Then you actually implement the policies. So that's step 4. And then step 5 has to do with the normal monitoring and care and feeding.
Okay. Yeah, those seem pretty typical. But again, it's like a best practice. So is there anything I should be thinking about if I've got, my microsegmentation policy set up and my enforcement points deployed and so on? How do I monitor that? Things I should be thinking about in terms of monitoring and ongoing auditing to make sure the policies are actually having the effect I want?
Yeah, this is one of the areas that I think is straightforward in concept, and it's a little bit more challenging in execution, because if you are doing true microsegmentation, only something in that path has visibility to that network traffic. So if it's tunneled and or encrypted. Now, there's a difference between encapsulated and encrypted. And sometimes people will just say something's tunneled. It could be either one. So if it's encapsulated, it's typically not encrypted. It's just kind of, you can almost think of it, I hate to put this analogy, you can almost think of it as like having a VLAN header where it's just like, this is your pipe, but it doesn't obscure it from an outside observer, versus something that is also encrypted. So, if you talk about those, overlay VPNs or any of the ZTNA products, right? All of those things are going to be encrypted. Even on the LAN side, some things might be encrypted. So depending on if a networking vendor is using MACsec, that is a layer 2 encryption protocol that's standard. At Mobility Field Day recently, Nile presented, that's one of the mechanisms I think they use there. So you could get that encryption all the way down at layer 2. And so in that case, if you want to monitor that for security or performance, you have to do it within that ecosystem. And so I think probably you can start to understand the complexity of, let's just say there's a traditional network and you've got, in a campus, you've got some of this user to resource model, some of this, device or land-based segmentation. If you use ZTNA product A for that user use case, and then you're using network vendor solution B for this kind of LAN microsegmentation, you don't have visibility across the whole environment. You've got visibility within that user population, and then you've got visibility within that separate device population.
So we've referenced a couple of, vendors as we've gone through the conversation. Do you have kind of like a mental model for what the product landscape looks like, sort of given your 3 sort of approaches to zero trust and microsegmentation, like land-based, workload, and user to resource?
So I'm going to mention name. Now, I would love for any of these companies to come on and explain more about what they do. And I'm not giving these as endorsements or recommendations, but just to send you off down the right path. If you're going to start, Googling or researching, I would look at these companies and or their direct competitors. So in that land-based microsegmentation, so kind of going in reverse order now, the first true product I saw in this space. So let me caveat before like Aruba and Cisco and everybody else gets mad at me, because a lot of the traditional networking and NAC vendors had, solutions where they could create more granular tunnels between things and do some stuff based on roles. No offense to anybody, a lot of that just didn't scale and work well. So I'm not counting that. Not that it's not a viable option. If you have that in your environment and it's working, fantastic. But the devices that were truly meant, to start micro-segmenting, there was a product called air gap networks. Horrible name, because that's a phrase we use, right?
Right.
But last year, Air Gap Networks was acquired by Zscaler. And before Zscaler acquired them, they did something really cool. They basically sat on the network, and this is grossly oversimplifying it, but they acted as the default gateway for whatever subnet you pointed to them. They serve DHCP. They throw a /32 on the endpoint, and therefore they control all of the traffic coming off of that endpoint.
Okay.
So there is no layer 2 adjacency for that endpoint other than that gateway. Now, one, that's a gross oversimplification. Number two, Zscaler has added a lot of stuff to that product since the acquisition, and they have merged consoles and virtual appliances with their traditional offerings. So that is definitely one of the solutions I would love to have come on here and talk more about what they're doing. The other, in this kind of land-based micro-segmentation, I would say, I mentioned Nile, and I'm kind of mentioning this because it's a completely different approach than what AirGap is doing or whatever Zscaler is calling that product now. So Nile's interesting in that you use their equipment, their switches, their APs, and therefore they control all the traffic. And they do it virtualized. So again, kind of think of, something more like that VXLAN construct. And because of that, they terminate traffic back to what they consider their head-end devices within their little service block or infrastructure. And that functionally kind of then works similarly to the way I described that AirGap Zscaler solution, only functionally it's a little bit different. So you get the same end result, that the endpoint has nothing that's layer 2 adjacent unless you explicitly allow that in a policy.
Okay.
So getting into the workload microsegmentation, this is the more traditional microsegmentation vendor space where we're looking at like Illumio, Guardicore by Akamai, that type of product.
Would you put NSX here and maybe Cisco ACI?
Yep, definitely Cisco ACI would go in here, and NSX. Then the user to resource segmentation, I would say, is, encompasses all of those ZTNA and SSE type of products. So the traditional Zscaler offerings, Netscope, Cato Networks, Palo has their Prism accessing. Yeah, Cisco has something, Aruba has something, Juniper has something in the space. So that's kind of the class of that user to resource. Again, think of that as a VPN replacement, even though it does much more than that.
Well, that brings us to the end, JJ. I hope that was a helpful overview of microsegmentation and sort of where it relates to zero trust and zero trust network access. And hopefully you're not more confused than when we started this episode. I feel like I've got some clarity. We did mention a lot of resources, including that CSA Zero Trust for Infrastructure white paper. We'll have a link to that in the show notes. And we'll link to some of the other vendor solutions we mentioned as well, although even this is a non-sponsored episode. It's just to give you a short list maybe to go start looking. Thank you for listening. If you've got an idea you want us to cover or something about this conversation spurred a question you have, you can always hit us up at packetpushers.net/FU. The FUs are follow-up. We do love when listeners reach out, and we try to take every question seriously and respond when we can. And Packet Protector is part of the broader Packet Pushers podcast network. That network includes a dozen technical podcasts, all aimed at your professional development. We cover networking, security, IPv6, DevOps, leadership, and more. There's an industry blog, 2 weekly newsletters, a community Slack group, a YouTube channel, even an IRC group if that's your jam. You can find it all at packetpushers.net, all free with no login required. And remember to stay safe out there.